Okay, so Assalamu alaikum, dear students. Welcome back after the Eid al-Adha. I hope that you had a very good time. Today we are going to start the lecture 18 of this course. The last two lectures we were talking about hashing. We discussed that. We discussed about the introduction of hashing, what the operations. In another lecture we discussed about the collision handling techniques, but we couldn't finish. We had a pending topic that was called double hashing. So this will be one of the topics of today. Using the idea of hashing, we will see one of the string matching algorithms. It's called Rabin Karp algorithm. So, and after finishing that, actually there will be further topics of hashing that is not possible to be covered in this course. You can check this with your self-interest. And then we want to move on to a new data structure. It's called Trie. Okay, so they will be giving you some ideas about this data structure, and then in the next lecture we will complete that one, inshallah. Okay, so without further delay, let's start. So as I was saying that we're talking about collision handling techniques of hashing, and we have saw that actually we can have linear probing, quadratic probing. Those are some ideas, and separate chaining was another idea. So double hashing falls under the open addressing category, right? And in open addressing, we saw that calculate the hash function. Whenever there is a collision, we take the help of a collision handling strategy, right? So we call that as FI. Now, there were different definitions of FI. For linear probing, FI equal to I, quadratic probing, FI equal to I square. Similarly, in double hashing, so we have another definition of the collision handling strategy. So let me write it down. So here, actually, the name is suggesting me that it's called double hashing. The double word comes from, actually, the concept is here, we will use two hash functions. Okay. So that's why the name double is coming. The initial hash function will give you a value. And then if there is a collision, you will take the help of a separate hash function, I mean the second hash function, to get a new index. Okay. So the idea is f of I will be now equal to I multiplied by a second hash function. I'm calling it hash 2 of x. Okay. So now this hash 2 of x will be defined. It can be defined in different ways. Actually, there is no definite. I mean, what should I say? Definition. There is no particular definition of this. This varies based on the different implementations. Even in the exam, if I ask you to do it using double hashing, actually I will explicitly mention that what is the second hash function. So previously, for linear probing, it was only I, or quadratic probing, it was only I square. So I didn't need to mention that what is the second function or like that. The name actually carried the meaning. However, here, so there is a separate definition of this hash function. Let me write it down. So the second hash function, first of all, one observation here is if this hash function gives the value 0, in that case, fi will carry no meaning, right? Because it is going to be multiplied with I. So it should be, it should not return 0. So out of many choices, actually, let's choose one of the options. So here, actually, I'm choosing this function. Okay, so here I'm taking the modulus operation based on a number r. Okay, and then I'm subtracting again from r because the subtraction means actually if the modulus results into 0, subtracting from r will give me a non-zero value. So this is just an idea to avoid the 0 values. Here, the value of r can be anything. So the better choice is to choose a prime number. So for today's demonstration, I'm just choosing r equal to 7. There is no specific reason for that. You can choose it in different ways. Double hashing actually contributes by handling the clustering problem in a different way, mainly. Previously, we saw that although linear probing and quadratic probing, they had the different ideas. However, they both of them were suffering from clustering, whether it's primary or secondary, whatever you call. However, double hashing has its own idea for handling that. So let's have a look. We will repeat our yesterday's example. We want to insert the numbers 89, 18, 49, 58, and 69. Okay, so these are the numbers that I want to insert in the table. The table size is same as the previous example. It is 10. So let's draw a table of size 10. Okay, so let's start the demonstration. So first of all, if I try to calculate the hash of 89, so the initial idea is 89 plus f of 0, right? So in the beginning, I is equal to 0. So when I is equal to 0, actually the f function results into 0 because it's multiplied by I. Modulus 10, so of course it will be 9. So there is no collision. So and we insert 89 here. Similar to this function, if I want to insert 18, the result will be 8. There is no collision, 18 will be inserted. Very good. Now, if I want to insert 49, so if I want to calculate the hash, how will it work? So 89 plus 49 plus f of 0 modulus 10, it is 9. So here is the collision, right? So I have to use a strategy. And as we are using double hashing, so we have to take the help of a secondary hash function. So here I'm taking I equal to 1 now. When you calculate I equal to 1, first of all, you have to calculate f of 1. How will it be calculated? 1 into hash 2 of 49. What is the definition? 49 means actually 7 minus 49 modulo 7. So the value will be 7. So is it the index? Actually, it's not the index because it has to be passed through the initial hash function. So I have calculated fi. So actually I have to pass it to the hash function. So 49 plus f of 1, right? Because so this is the complete procedure. So 49 plus 7. What is this? Just 6. So this is the index, right? So do not misunderstand. I just calculated f of 1 separately and got 7. Pass the value here. So 49 is inserted into index number 6. Very good. Now I'm going to insert what? I'm going to insert 58. About 58. So first of all, it will be inserted. Telling me to be inserted in index number 8, but it's a collision. You cannot do that. I should try for I equal to 1. For I equal to 1, let's calculate f of 1. 1 into taking the help of the second hash function. So 7 minus 58 modulus 7. 7 minus 2, 5. So it should be passed in the initial hash function. So for I equal to 1, the original hash function will work like this. 58 plus f of I modulus 10, 8 plus 5 modulus 10, this one, which is 3. So 58 is now inserted into index number 3. Now have a look. If I want to insert 69, so I have to calculate the hash value, of course. So how will it be calculated? Hash of 69 will return me 9. So there is a collision. Now, if I so to resolve this, let's take the help of the second hash function. So f of 1 equal to 1 into hash 2 of 69. So it is what? It is 7 minus 69 modulo 7. It is 7 minus 6 equal to 1. It will be passed the initial hash function. So hash what? 69 69 plus f of 1 modulus 10. It will be what? It will be 0. So it is first here. One observation here is actually, if you recall linear probing or quadratic probing, what happened? Here, first of all, 89 is ending with 9. So I could insert it within one chance. 49 is also ending with 9. So I needed two chances, right? And if it was linear probing or quadratic probing, in that case, what would happen? For 69, will I equal to 1 give any different value? No. I equal to 1 will give the same value as 49. The remainder will be same. The index will be same. Then I have to try I equal to 2. So by no means, actually, linear probing or quadratic probing can never insert the number within one chance. Sorry, two chances here, right? I mean, one attempt to resolve the collision, right? Definitely, it would at least take I equal to 2. Let's show you another number. Let's try to insert 79. So 79 will be resolving into 9. It is a collision. So my first attempt is I equal to 1. So I equal to 1. So if you calculate f of 1, it will be what? Hash 1 into hash 2 of 79. So it is 7 minus 79 modulo 7. So 7 minus 2, 5. So the initial hash function is giving me 79 plus f of 1 modulus 10. It is what? 84 modulus 10. So it will be 4. Have a look here. It is 84. So have a look. In the first attempt of collision handling, I have got 3 different values. Although the numbers ended with 9, I'm getting 3 different values. However, if it was linear probing or quadratic probing, it would never happen. Rather than that, a cluster would form. For linear probing, it will be, we called it primary cluster because actually they were just one after another. And for quadratic probing, it would be sparsely located, but still it would form one type of cluster. I hope that you understand. In double hashing, this issue is not coming up. Okay, so by this strategy, actually it is trying to resolve it's trying to reduce the time of insertion, or even when you search, when you search, actually, for let's say you are trying to search 79. So if you are trying to search 79, first of all, you will check I equal to 0. It's not there. I equal to 1. It will be there. But if it was quadratic probing, at least you have to check until I equal to 3. Okay. So this is or at least I equal to 2, maybe. I don't know. I have to do it. No, of course, I equal to 3, because already 3 numbers have ended with the value 9. Okay. So this is the idea of double hashing. Okay. However, if you cannot find for I equal to 1, of course, you have to try I equal to 2, then I equal to 3 in this way. But the chance of conflict, or should I say collision, will increase as the load factor is increasing. Okay. But if you can maintain the load factor to a considerable amount, hopefully you will always get the free slot within a few attempts. So what is the number of the load factor? I didn't check it. You can check it out later on. Okay, so I will not cover any further collision handling technique. I have taken this example from the book of Mark Allen Weiser. I will give the link in the Google Sheet. Okay, so there are actually many other techniques in that book, but I am not covering it. But if you are interested, you can have a look. So, but that will not be part of the syllabus. Okay, so questions for double hashing. Any question about double hashing? 42.
Sir, can you guarantee that the table will be filled?
No, actually, it cannot be guaranteed. Okay, but for quadratic probing, I said that if it crosses 50%, there will be a chance of collision. But here, I'm not sure about that. I didn't check the accurate number. But there's no guarantee that the table will be filled. Okay. So I think there is no further question on double hashing. Now we'll be moving on to the Rabin Karp algorithm. Okay, so actually it's a string matching algorithm, and the idea is very trivial. Actually, you already have what should I say? You already have developed this algorithm in the first lectures discussion. Okay, so when I will tell this, you will understand that why I'm saying like this. So in the Rabin Karp algorithm, the problem statement you can think like two strings are given. One is called text and another is called the pattern. Now your task is to find out whether the pattern exists inside the text. Okay, so very simple question. Now let's assume that so this is my text, and this is my pattern. ABC is my pattern. So if I do not know any optimization or anything, what will I do? So here the length of the pattern is 3. So what will I do? Actually, first of all, I will start comparing up to 3 characters. So I'm calling this as the window. So first of all, I will take a window of size 3. So I will compare character by character. It doesn't match. I slide the window 1 step to the right. Okay. So after sliding, I will again compare. I'm a bit lucky here. I will get the match. So maybe if I'm trying to compete, if my pattern is DAE, so after ABC, I have to check the window BCD. There is no match. CDA, there is no match. Then DAE, there is a match. Okay, so I will get it. In the worst case, actually the string might not be there, or I can get the match for EAB, right? So that's the worst case. However, actually this algorithm is a brute force one, and the complexity is order of m into n. Here, what do I mean by m? So the length of the text, I'm calling it as m. The length of the pattern, the length is n. So for each value, actually I have to compare one with another. So roughly I can say that there will be m in comparison to the worst case. Okay, so the complexity is m times n. However, as you know, hashing. Now you can utilize the idea of hashing here. Okay, so let's see that if someone from your side can give me the idea. এটা কে বলবে? এটা ফাইরোজানিকে বলে ফেলো। এটা কিভাবে করব? Can you how can I use hashing here? করতে পারবা? চিন্তা করো, দেখো পারো কিনা। ওকে, মাইক ইজ নট ওয়ার্কিং। আচ্ছা, তাহলে তোমাকে ছেড়ে দেই, আর একটু কাকে জিজ্ঞাসা করা যায়। বলবে হচ্ছে এই এটা এই শিফায়েত বলবা নাকি? আলিন মোহাম্মদ শিফায়েত বলে ফেলবা? আচ্ছা, অর্পা বলে ফেলো। অর্পা can you tell? অথবা আচ্ছা, আর কে পারবে এটা? Right? I mean, the question is how can I utilize the idea of hashing here? Very easy, trivial. একটু চেষ্টা করতে পারবা, হ্যাঁ? এটা কে বলবে? এটা হচ্ছে কাকে জিজ্ঞেস করা যায়? এটা আমাদের হারিয়ে যাওয়া ক্যামেরা প্রতিনিধি রিফা বলে ফেলো। বলতে পারবা?
মনে হয় না।
গরুর মাংস খেয়ে সবাই সব ভুলে গেছে। হ্যাঁ, আচ্ছা, কে পারবা একটু হাত তুলো। হ্যাঁ, কোরবানির মাংস খাওয়ার কথা ছিল, হ্যাশিং খেয়ে ফেললে হবে? আচ্ছা, কে বলবা একটু হাত তুলে ফেলো। একটু নতুন মুখ পেলে তাকে জিজ্ঞেস করবো, আদারওয়াইজ সহজ আলোচনা করেছিলাম। এটা কে বলবে, কি কাফি বলতে পারবা? কাফি,
নো স্যার।
এই তুমিও অনেক মাংস খেয়ে ফেলেছো। আচ্ছা, তাহলে আচ্ছা আচ্ছা, সিরাজ আল আরিফিন বল, সমস্যা।
Sir, I think we can take every three elements or every three characters and hash them, and later we can hash the pattern through. Then if we can just match them, we'll find it.
Okay, so if you understood his idea, let me rephrase. So first of all, the idea is I'm saying that the window length is n, right? So the length of the window is n. N here is 3. The idea is actually instead of comparing for all windows character by character, I will first of all compare the the hash value of the window. Hello. Yes, you can hear me. So let's say the window, the hash of this window is x. So the hash of the pattern is x. So I will calculate the hash of AAB. So the value, if the value is x, only then I will compare character by character. So for the second window, here I will get the value x. So what will I do? I will then, only then when the hash matches, only then I will compare character by character. So if the hash does not match with any window, that means the pattern is not present, right? That means the pattern is not present in the uh, um, in the text. Okay, so here, for example, the simplest hash function can be what? So you already saw in the first lecture that if the string is given, so the simplest hash function is add all ASCII values. Okay, so if you just add all the ASCII values, so let's say ABC 97, 98, 99, you just add the three values, and then for each window you add the three ASCII value of the three characters, and then you try to check if the value matches, only then you will compare character by character. এটা সমস্যা কি বলতো? এটা কে বলবে? এটাও কি ভুলে গিয়েছে নাকি দেখি তো। এটা বলো, এটা কাছ থেকে পারতে হবে, নাহলে আজকে অ্যাটেন্ডেন্স অর্ধেক করে দিতে হবে। বলো দেখি।
স্যার লেন্থ মেবি স্যার সমস্যা।
No. That's not the reason. Let's say I'm just adding numbers. Okay, actual number হলে সমস্যা নাই। So it was adding the constant. What's
Sir,
the
permutation of the string.
again?
তো চেক হবে।
A permutation of the main string.
Yes. So here the problem of this approach is for ABC, BAC, CAB. Actually, for all of them, the hash value will be the same. So although I'm trying to optimize, in the worst case, maybe all the window is giving me the same hash value. So still it can result into order of m times n. So your hash value should be unique for different words. Okay. So let's say I have designed a very good hash function. It's giving me unique value for every words. Okay. In that case, what will happen? So if I do not need to worry about the conflicts between two words, in that case, what will be the complexity? এটা একটু বলে ফেলো তো, এটা কে বলবা? শিহাব পারবা বলতে? What will be the complexity in that case?
So in what case?
So if there is no conflict, okay. So if there is no conflict, I mean the hash value of the word is unique for every possible word. Okay.
It should be m by n. M divided by n.
No. Any other idea from anyone?
N plus
1.
Raise hand, please. Is this able?
n plus m.
M plus n. It's close but not the accurate value. Any other ideas? হাত তুলে বলে ফেলতে সমস্যা নেই। Anyone? 42 বলবা? 40, 40?
So it will be M, order of M.
Order of M is actually correct, but just not the accurate value. I'm asking for the accurate value. How many times will I have to calculate the hash value?
Initially, I have to calculate it for n times. Then
I mean, how many windows will be there? That's the
It should
right?
be M minus N plus 1.
Right. So M minus N plus 1 windows will be there, right? So in the worst case, maybe I have to compare, I have to calculate the hash value for all of them. Calculating the hash value is a constant operation. And as I only have to compare the characters once if it is present, so I'm assuming that that is a constant operation. So in total, I can say that it is order of M minus N plus 1. Okay, but roughly you can say that it's order of N, order of M. Okay, but this is the accurate value. Okay, so you can check it out how many times the window can slide. Okay, so that's you can check it out each time. Okay, however, actually it is only true when the hash function is good enough. Okay, I mean it is only true when the hash function is good enough, because if the conflict occurs in that case, actually in the worst case, it will be order of M times N. Okay, moving on. Now, how to design a good hash function? So you already know that to design a good hash function, let's say A, B, C, instead of adding the numbers directly, I can just write like A into 10 to the power 0, B into 10 to the power 1, C into 10 to the power 2. Actually, 10 here is a random number. You can pick any number you want. Okay, that's not an issue. So if we can use it like this, in that case, what will be the benefit? Benefit will be A, B, C, C, A, B, or different permutation will give me different hash values, right? So in that case, what I assume is I will only get same hash value as the pattern when it is actually the word. But still, as there is a chance of collision, so only for that case, I will match character by character. Okay, and our expectation is we will do it only once. That's why we are doing it like that. Okay, so any questions up to now? How will this algorithm work? Yes.
So in case of the hash function, for example, in this example, we have A, B is the first string we convert.
Okay.
So when you move on, you have to remove the value of A.
Yes. So I will talk about that. How will I do that? Okay. So before that, for calculating the hash of the string, actually the formula is like, if I write it down, string I into 10 to the power what? 10 to the power I minus 1 is from I equal to 0 to the length of the string minus 1, right? So it's very trivial. Okay, very good. Oh, I think it's I, right? I minus 1 not needed. Okay, very good. Now, so if this happens, actually, what will happen for every window, I have to calculate the hash value, and then if it matches, I will need to make the comparison. Now, still, actually, this calculation of the hash function can be further reduced. Okay, so I don't need to recalculate it again and again. So if I observe it carefully, actually, I can optimize this calculation. Okay, so let's have a look. So let's use my name. Okay, I think for simplicity, I can use another thing. I mean, for A, B, C, D, E, let's say that first value of A is 1, B is 2, C is 3, then 4 and 5. So it's just an assumption. Now I have a text. What is that? A, B, C, E, D, E. It's a long text. Now the pattern here is it's a C, E, D. Okay. So first of all, I have to calculate the hash of CED. How to do that? So 3 into 10 to the power 0, 5 into 10 to the power 1, 4 into 10 to the power 2. So it is 453, right? So I will actually compare only when any window is giving you 453. So first of all, what is our objective? So I will start from ABC. So I will calculate the hash value of ABC. What is the hash value of ABC? 1 into 10 to the power 0. B is 2 into 10 to the power 1. C is 3 into 10 to the power 2. What is the value? It is 321. So it doesn't match. So what I have to do is actually, I have to slide the window. So I have to calculate BCE. For BCE, what is the idea? Idea is 2 into 10 to the power 0, 3 into 10 to the power 1, 5 into 10 to the power 2. So whatever the value comes, it is actually 532. Right. এখন, how can you optimize the thing here? So one observation here is actually this BC, the ASCII value of this BC is the same as here, right? So if it is a string of length 5, what will happen? The first window, the first window will be the first window will be ABCED, and the second window will be BCEDA, right? So, and even if it is larger, in that case, actually, what is the difference? What the point I'm trying to make is only the first and the last letter is changing, okay, and the rest of the thing is the same. If I observe further, this 2 is same as this 2, 3 is same as this 3. However, 1 is becoming 0, 2 is becoming 1. Okay, and then you have to subtract this and add this. Okay, so the idea here is actually if you have, so let's say that this is the old hash. Okay, so first of all, if you can subtract the character to be discarded, I mean the first character, you can track it by any variable. So let's say the ASCII value, ASCII of I mean, what should I say? So ASCII of the discarding character. Okay, let's call it ASCII of discard. This can be anything. So let's say it is X. So when you do this, so first of all, what is your current status? When you have calculated ABC, your status is like this: 10 to the power 0 plus 2 into 10 to the power 1 plus 3 into 10 to the power 2. So when you are discarding this part is removed. Now what you have to do? You have to reduce this 1 to 0, this 2 to 1. How can you do that? It's nothing but x equal to x divided by 10. There is the second step. So once you do that, this 1 will now be 0. This will now be 1. So what is left? The left is actually the new number into 10 square. Right? So the formula will be now x equal to x. Sorry, I mean you can call it that it is a new hash function. The new value will be x plus 10 square into ASCII of new character. Okay, and as you are maintaining a window, you are sliding it, you can easily maintain. You can easily understand that what will be how to track this discarding character and the new coming character. Okay, so once you can do that, actually the new coming character is what? 5. So this 5. So this formula is same as this. And you can say that, sir, this formula is looking same as the before, but it is not the case, because once you have the value 321, the first step is discarding 1, so it is becoming 320. Then 320 divided by 10 is 32. Then 32 plus 5 into 10 square, which is 532. So it is only playing with a single integer. Okay. And this will be even further evident when the pattern, you assume that the pattern has length 20. In that case, you only have to access the ASCII of the first and the last character, and rest of the thing you are not even touching, right? But how if you don't do this, what will happen? You have to check the ASCII value of every window, do the multiplication, addition, and then get the hash value. It's almost as if I'm comparing character by character. there's no meaning of using the hash unless you do this sort of optimization. You understand? Because it's just like for comparing, you have to access every letter. Now, for calculating the hash, if you have to access every letter, then what's the meaning of doing this extra burden, right? Questions? What do you do?
So in case of this, can you use also multiplication? Like if you take it inverse, like 3 times 2 to power, not 2, 10 to power 2 plus 5
Yes,
times.
you can do that. In that case, you have to adjust the formula accordingly. Okay, so if you do this in reverse, so these 3 lines, you have to maybe you will need multiplication in that case, because you will in that case the power have to be raised, right?
Yes, sir.
Okay, so you have to do that accordingly. Both of them are correct. Okay. Question. Did you actually understand the benefit of doing this?
So I didn't understand the advantages of this.
আমি আবার বলি, হ্যাঁ, here actually, okay, let's assume that I will not utilize these formulas. হ্যাঁ, আচ্ছা, তাহলে সমস্যাটা কি হচ্ছে? এখানে first of all I have to calculate the window ABB. হ্যাঁ, for that, how do I do that? 1 into 10 to the power then again 1 and then into 2 into something like that. Okay, then I have to calculate for ABC. Now for ABC, again I have to start from A 1 into 10 to the power 0. Then B, the ASCII value of B into 10 to the power 1. Again for BCD, I have to access the ASCII values again. Now I want to use the hash function. So one of the objectives was I want to reduce the operations, right? According to calculate the hash here, I have to check the ASCII value of every character for every window. So if the pattern is bigger, maybe the window might contain 20 or 30 characters. So I do not, it's directly the numbers are not there, right? Maybe I have to do some subtraction to get the actual ASCII value, or maybe convert it into some integer, whatever. So instead of this, okay, so it is actually increasing the complexity. So instead of this, if I can do this approach, তাহলে কি হচ্ছে, for if the window is size 5, what's happening? I have to access the ASCII value of every character, right? For the first calculation. Good. After that, when let's say it's not matching, so I have to calculate for the next window. But in that case, I only have to access the ASCII value of A and just subtract the ASCII of the first character. In this way, I will move on. So instead of accessing the 20 characters separately, I will only need to play with 2 of them. So it is reducing the time or operations. Okay. বারবার পুরোটা ক্যালকুলেট করতে হচ্ছে।
Yes, sir.
Okay, thank you. What do you do?
So in that case, the worst case scenario can it be like n times m? Because say there might be a possibility of cohesion.
Okay, so actually, before answering your question, here this idea of this hash function. So here, although the formula is telling me that for every window or every string, I have to calculate it completely, but I'm doing some sort of optimization here. This sort of idea is called the rolling hash function. Okay, as if the function is rolling through the string. Okay, and calculating. So it's called a rolling hash function. Now, although I have designed a very good hash function, I'm believing that, but still there can be collision. Okay, that's why we are just not directly believing if the hash values are same. I'm not getting into any conclusion, rather than that I'm comparing character by character. So if your hash function is good enough, in that case, the assumption is it will be happening only once. Okay, so you have to design the hash function in such way that the collision doesn't happen, or the chance is very low. Okay, so that you don't need to consider about that. But if it is MN, in that case actually same as brute force. So this will be all about the Rabin Karp algorithm. You will be implementing it in the lab, don't worry. Okay, so I will try to give you some applications on this. Questions? So up to this Rabin Karp algorithm, this is the syllabus of the quiz. Okay, দুইটা টপিক ছোট ছোট একটা ল্যাবেও থাকবে, এটা পড়তেই হবে এদিকে করে ফেলো 240.
So we when the window size is long, like say 20 words, then we need to use modulus, right? Mod.
মানে your other it might overflow এরকম.
Yes.
Yes.
Then if I mod the value, afterwards I try to divide it by the base value. I mean x by 10, the line here. Will it work on the mod?
X by 10 আচ্ছা,
মানে mod করার পরে তো ভাগ কাজ করার কথা কি?
so you are doing modulus in which part?
আমি তো স্যার প্রত্যেকবার হ্যাশ ফাংশন ক্যালকুলেট করার পরে একবার মডুলাস চালাবো,
হ্যাঁ।
তারপর রোল করার সময় একবার ডিভাইড করতে হবে। তো মডের উপর কি ডিভাইড কাজ করে?
সেটা তো আমি সরাসরি উত্তর দিতে পারলাম না।
Sir, don't we use modular inverse in that case? That's the substitute of division, right?
I'm not sure about that. এটা দেখতে হবে। হ্যাঁ, আমি দেখো আমি কোশ্চেন ঠিক বুঝলাম কিনা। মানে আমি এখানে হচ্ছে মানে when you are calculating the hash function, you have to do the modulus operation. হ্যাঁ, then মানে সমস্যাটা কোথায় হচ্ছে আবার বলতো আমাকে, আমি একটু এটা পড়াশোনা করব তাহলে বুঝতে পারি না।
Sir, let's suppose the string has a length of say 100. In that case, we might need 10 to the power 100, so that might overflow.
Right. হ্যাঁ।
Also, there may be reasons like when we're calculating the power, let's say it's not 100, it's say 10 to the power 5. In that case, the modulo might be our calculating the power might be very slow, so we might need to do it in an efficient way, like we do with big mod, so that it occurs in log n. So there's another issue.
ওকে, যেমন মানে এই ইস্যুগুলা আমাদের ইকোনমিক কিছুটা হচ্ছে আমাদের অ্যালগরিদম কোর্সে কিছুটা পড়ানো হয়। হ্যাঁ, মানে বক্তৃতাটা দেখে। এখন আই ডিডন্ট চেক দিস টপিক আর কি, ঠিক আছে, আমি এই পার্সপেক্টিভ দেখি না, বাট মানে ইটস ট্রু দ্যাট ইফ দ্য স্ট্রিং সাইজ ইজ ভেরি বিগ ইউ হ্যাভ টু ইউজ দ্য মডুলাস অপারেশন। ওকে, নাও মানে what will be the policy, then will there be any conflict of division? এটা নিয়ে একটু দেখতে হবে। হ্যাঁ, এটা আমি চেক করে নিই। কেমন?
It actually be solved by the way Idrisa told, like if we calculate the number from reverse order, then we won't use the mod the division anymore, we will use multiplication. So I think that will solve the problem.
ওকে, আচ্ছা, ডিভিশনের সমস্যাটা কি হচ্ছে?
মড করা ভ্যালুর উপরে ডিভিশন আমি যতটুকু জানতাম কাজ করে না, মডুলার ইনভার্স ইউজ করা লাগে।
Yes, sir. Inverse works in that case. Inverse use করলে তখন ওটা রিজলভ হচ্ছে।
আচ্ছা, মানে আর হি ইজ সেইং লাইক ইফ আই ডু ইট ইন রিভার্স অর্ডার, জাস্ট এটা অন্যদের জন্য একটু বলে দেই, মানে if we do it in reverse order, in that case what will happen? The formula will be like 2 into 10 square, 3 into 1, 10 to the power 1, 5 into 10 0, right? So in that case actually I have to subtract this, and then it will be the beginning of the next thing, right? So in that case, instead of division I have to do multiplication, so that 1 becomes 2, 0 becomes 1. Okay, so his logic actually, the thing Modul is saying, yes, that after subtraction actually the division might make some problems. In that case, if I just reverse the way of calculation, okay, so instead of 0 I can just write, instead of I can write len minus I. Okay, So this will help to some extent. Okay. So but this is the same thing, but for bigger ones, I have to check. Okay, but very good observation. Okay. Further questions on Rabin Karp? Okay. So if there is no further question, actually this will be the conclusion of Rabin Karp algorithm. Okay, you will be doing it in a lab task. So then we will talk about it. Now, as we're talking about strings, we will now introduce you to a new data structure. It's called Trie. And this Trie data structure is very good at searching different strings from a set of string. Okay, so it's very good at string searching. Okay, let me give you a scenario that, let's say, in a city there are many, let's say there are 1,000 people living, or many people living. So you are trying to store their numbers in a phone book. Okay, so so all the citizens, so you are storing their numbers in a phone book. Now, when you have stored their numbers, actually let's say there are 1,000 citizens, so there are 1,000 names. Now you are trying to, so you are getting a new string, and you have to check that whether this string is within this phone book or not. So this is the problem statement. Now, how can you do that? So again, the brute force approach, you can just go for every name and go label character by character. Or another approach can be, you can take the name, hash value of the name. Okay. And then you can, so similar to Rabin Karp, you can do the string matching. But there are, Trie can do it in even further efficient way. So the idea is actually, let's say if the length of the string is L. Okay, so Trie is telling me that actually it can do the searching in order of L. Okay, so if I want to search, let's say, for example, if I want to search Rafi, in that case there are 4 letters in Rafi, so it can do it within 4 operations. So it doesn't matter that how many records are there in your phone book, or whatever the length is, what is the variation of the length, what is the maximum or minimum length, it doesn't matter. So if you want to search a string that is already stored in a Trie, it can be retrieved within order of L. Okay, L means the length of the string. Trie is a very good structure, good data structure for retrieving information. Okay, retrieving information, and I read somewhere that the name is coming from here, the retrieving. So from in the middle there is a Trie. Okay, so from here the name is coming. Okay, and so today actually I will not go into the detail, but I will show you the operations. Another name of the Trie is called prefix tree. Okay. So prefix tree. So for example, if I take my name, okay, so S is a prefix, SA is a prefix, SAB, SABB, SABBI. Even you can consider the whole string as the prefix of itself. So you have to start from the beginning, and you can move up to any character. Okay, so Trie utilizes this idea of prefix to store and retrieve the values. That's why it's called a prefix tree. Okay, so the catch from here is actually it is actually very fast in retrieving information about whether the string is present or not, and in searching. Okay, so let's have a look at how informations are stored in a Trie. Okay, so let's assume that I have a few words: algo, then algia, then also, from Troy to Tommy. So I have different words like that. Okay. Now the idea of try is actually here I will implement it using a linked list. So as many other linked lists, so there will be a root of the tree. So in the beginning, the root will be so there is nothing but the root, and the structure is like so. Here let's call the structure as node. Okay. So in the each node, actually there will be pointers inside the node. Okay. So there will be next pointers. In fact, 26
Sir,
of
we
them.
cannot see what you're.
Okay, wait. Sorry. Yeah, can you hear me? বুঝতে পারছো? Wait a minute. Okay, I'm starting the sharing again. Okay. So I think you can see it now. So in the root, so I'm calling it a node. Okay, so inside the node, the idea is you will have dedicated next pointers. I mean 26 of them. And what does this 26 mean? Actually, have a look here. So from the root, so if there is a character that starts with A, there will be a pointer dedicated to A. And then again, from that node, again, there will be a pointer, I mean, 26 possible pointers. So, I mean, next 0 is dedicated for the letter A. And the second index of A next is dedicated for B. In this way, the 25th index is dedicated for Z. Okay. So what try does is actually, whenever a new word is coming, it tries to check that, okay, which letter does it start with? So in the beginning, in my try, everything is null. I mean, all of these pointers are in the beginning initiated to null. Okay, so I'm assuming that all of them are null. So I'm trying to insert the word algo. So first of all, here from the root, there is no dedicated pointer for A because it's null. So I will create a dedicated pointer for A, and then I will create a new node. Okay. Then again, from A, I am trying to insert L. So from A, there is no dedicated pointer for anyone. So I will create a pointer for L, create a node. From here, I will create another node. From here, I will create a pointer for 0 and do like this. If you want the syntax, actually, it's like if let's say you are starting from the root and it's called current. So if the current next, let's say if you are trying to do A, So if the current next A is null, so what you have to do, you have to allocate memory to that point. Okay, so what you have to do is, so you are doing it like current next, then there is an index equal to new node. Okay, so here the idea is from every pointer there can be 6, from every node there can be 26 possible pointers. All of them will be initially pointing to null. Then when a letter comes, and if the dedicated pointer for that letter is null, you will allocate memory, and then actually the next line will be current equal to current next and that location, right? I mean, from A you are moving to L, from L you are moving to O, G, from G you are moving to L. I will write the detailed code tomorrow. I'm just giving you the idea. So let's insert here the next letter, you will understand now. So for ALGEA, what's happening? From the root, for A, there is a dedicated pointer, right? So because the next 0th index is not null, so it means that there is already a node memory allocated to for A. So you do not create a new memory, rather than that you just traverse equal, I mean, current equal to current next 0. Okay, so you are coming to this node, and then from here you are checking that, okay, for L, is there any memory allocated? Yes. So there is already a memory allocated. How do you determine? Actually, for L, I think, what is the index of L? IJKL. So the L will be 11, right? So for L, actually, you will check that from A, is there a dedicated pointer for L? Yes. So you will come here. Then from L, there is a dedicated pointer for G. Then from G, actually, what you have to do, there is no dedicated pointer for E, right? So you have to allocate memory to the 4th index of next. I mean, E is 1, 2, 3, 4, 5. So it will be 4th index of next. So from here, actually, you will allocate memory, and then from here you will allocate another memory. Here the node is not actually storing anything for the time being. Rather than that, it's actually the pointer that is coming out of the node. It has the significance here. Okay, so I'm for the time being, I'm not storing anything in the node. Okay, it's just having it just has the information whether the next pointer for any dedicated letter is null or the memory is allocated. Okay, very good. So for let's say if you want to insert Tom, so they always start from the root. From the root, there is no dedicated memory for the T. So you assign memory and come to the next location. From T there is nothing, so you assign memory for O and come to the next location. For you assign for a memory for M, you come to the next location. If you want to insert also, what you have to do, so starting from the root, for A there is already something, so you come to A, the node for A, then you come to L. From L there is a memory for G. However, there is nothing for S or O. So from L you are creating location for S, and then from S you are doing it for O. If you want to insert the word toy, what's happening? TO, then from O there is something for Y. Now when this is happening, actually, what's the benefit of storing the data like this? First of all, it's saving a lot of space, because if we have the same prefix, I store it only once. Okay, so for inserting algo and also, actually, I don't need to store A and L twice. It is one of the benefits, storage saving. However, what's about the searching? So in the binary search tree, in the binary search tree, we store the numbers in such a way that we knew that in which direction I have to move. Okay, so similar to that idea, if you are trying to find out that whether also is a part of my dictionary or not, so I'm calling this set of word as my dictionary. It's not like the Python dictionary or something like this. It's just a set of words is called dictionary, let's say. So if the word also exists, what it means that from the root, there must be a pointer. Root next 0 should be not null. Is it the case? Right. It's the case. So if it is not null, so you come to A. From A, if the word also is present, there must be a pointer. The dedicated pointer for L must be not null. It is not null. So you're coming to the next pointer, L. From L, is there a dedicated pointer for S? Yes. From S, is there something for O? Yes. So as you have got also, actually you can say that, okay, it is a valid word for your dictionary, or this contact is present. Okay, it's present in the phone book. I have concluded it in 4 operations. I didn't need to check all of them, right? So there are many nodes in my tree. However, I'm just moving to the right path. Okay, so let's say you are searching for the word Tommy. So if you want to do it, so you see that, okay, starting from root, there is a pointer for T, there is a pointer from T, there is a pointer for O, from O there is a pointer for M, but from M you have nowhere to go, all the pointers are null. Even you don't need to check all the pointers, you will just check that from M, is there any pointer for M? No. That means this word is not present. Within 3 operation, even there are millions of words, or within 3 operation, you can tell that whether it is present or not. Very good. Let's say you want to check that hello, is it present or not? Now, starting from the root, is there any dedicated pointer for H? No. That means done. It's not present. Okay. So in this way, actually, from a set of strings, you can easily say that you can easily conclude that whether the string matches or not, whether the string is a part of your phone book or not, and so on. I will discuss about the searching algorithm and insertion and other techniques in detail in the next class. Okay. However, there are some other issues. For example, let me tell you some glimpse of those. For example, you want to insert to, the word to. That is what is the challenge? Already there is a pointer for T, and from T there is a pointer for O. So TO is already a part of your dictionary. So now you have nothing more to create. Now the problem is actually, so when TO is present, is it a word or a prefix? How do you know? For example, if you do not store any other marker, actually you will get also confused. If I ask that, okay, is ALG a valid word or not? So you will see that, okay, ALG is present, but it is not a word, right? It is a prefix. So how do I understand whether it's a word or a prefix? So for that, actually, if you want to tackle these sort of issues, a prefix can also be a word. What will happen? Or actually, if you want to store Tommy, so in that case, Tom is a valid word, Tommy is a valid word, but there is no way to understand whether Tom is a prefix or Tom is a word. What will you do? So for that, actually, whenever a word ends in the trie, you can maintain a marker. So for every node, there is a Boolean value. The Boolean value represents that whether a word ends here or not. So in the node, you can have a Boolean value, let's say whatever, n mark. So whenever a word ends at a particular node, you make the n mark as true. So you make the n mark as true. Okay. So at these locations, I have words that are ending, right? So whenever you are, so if I ask you that, okay, so if I ask that, okay, is toy a valid word? So you start from TOY, you come here, you see that, okay, it is present, but is it present as a prefix or is it present as a word? You ask the end mark of Y. Y is telling that, okay, it is 1. That means a word has ended here. you are asking that, okay, is TOM is a valid word or not? You are coming TOM. So at this point, for the M, the N mark is true. That means it's a valid word. However, if the word is like TOMM, in that case, you will come here and the N mark is false. That means that it's a prefix, but it is not a valid word. It is actually, the idea of try is also useful for spell checking. Okay, so for spell checking, what is happening? I gave it in the semester final of the last year. Okay, so you one have to make a spell checker. Okay, so what's the idea? So if you have the N mark, and I'm asking that, okay, is ALG a valid word or not? Or let's say I have written ALG, but your spell checker, what is the strategy? You are checking every word in the try. If it is present in the try, you are saying that it is a valid word or not. So you're coming to ALG, but you're seeing that there is the N mark of G is false. That means there is something wrong in that word. Also, you can, so in the binary search tree, there was a subtree size. I mean, you could say that, okay, how many nodes are under me? Similar question can be asked here, that how many words start with TO? I mean, how many words contains the prefix to? Okay. So for that, what you have to do? Actually, similar to N mark, you have to maintain another variable for every node. So when I pass through any particular node, that variable should be incremented, right? In this way, actually, so when TOY is inserted, when TO is coming, it is 1, or TOY it is 2, TOM it is 3, TOMMY is 4. In this way, actually, you have to store that how many numbers are under me. You can do that. So if I ask you that, okay, how many words are there? I mean, for example, I have stored all the names of your friends in the database. Then I'm asking that how many students are starting with Rafi? How many students have the prefix Rafi? So already there are 2 Rafis in your class. How do I understand? I will not check for every name. Rather than that, when the Rafi is being inserted, actually it's Rafi Hassan or Rafi Khan, whatever. So I will have the information, right? RAFI, when I go to I will tell me that how many names are under that node, right? So in this way, there are various cool features of try. So actually, if you can implement it properly, of course, the complexity is reduced to a great extent. The detail will be covered tomorrow. 238.
So is there any relation between try and BSD? Like
No. I mean, I'm saying that in the BSD, we just modified the idea of tree in such a way that searching was very easier, right? So we had a direction that we don't need to check the entire left side if it is in the right side. Similarly here, if the word starts with T, no meaning of checking the other 25 pointers. There may be 1 million word which does not start with T, but I don't bother. Store করা হয়ে গেলে আমি চেক কি করব না সেগুলো। হ্যাঁ, এটা তো সুবিধা। আইডিয়াটা সিমিলার। হ্যাঁ, ইতি স্যার। What to do?
Sir, for this spelling or the check spelling, I'm not. Can you hear me, sir?
I can hear you.
Yeah, I was asking. My question is about the spelling, the check spelling.
Yeah, what's the question?
Oh, sir, for that one, I'm not quite understand.
You don't understand. I shall repeat.
Yeah, if possible.
Yeah, of course. I mean, let's say you have written a paragraph. In the paragraph, you have written that algo also toy then summer. Okay, or let's say you instead of also you have write ALOS. Okay, now you are checking the spelling. So for checking spelling, algo, you are coming in the try, you get an N mark for O. It's the correct word. Spelling is correct. This is correct. Now AL, after AL for O, is there anything? Is there any pointer? No. So I'm saying that, okay, the dictionary is stored. I mean, all possible words in the world, maybe they are stored in my try. Now there is no word that starts with ALO. So I can conclude that there is a problem in this word. Okay. There is a mistake in this spelling. There is some mistake, but what is the mistake? I don't know. But there is something wrong here. That can be the conclusion.
Oh, okay, sir.
Question. Anyone else? We'll talk about these applications even in further detail tomorrow. Questions? Any other questions from your side? If it's not, then we'll be stopping the sharing. Okay. Now let's see today's memes. It's also sent from your friend. Okay. It's the first one. Okay. So some of the students are finding it difficult. So when he sees his pen to understand hashing, so he's very astonished. This is the first one. Then second one is this one. This one is better. Okay, so within 5 minutes, stress level is very high. Okay, he's searching that how to learn it without stress. Okay, so this is another one. The third one is actually these are sent by one of your friends. Okay, I didn't search for the name. Okay, so he's helping the humanity by keeping his identity hidden. Okay, so have a look at this one. Okay, so everyone is thanking him, right? So this is a good one. Okay, so this person has revealed that he is from cse2. Okay, to ভুল করে ফেলেছে 1 or 2 লিখতে পারতাম, narrow down হয়ে গেল সার্চ স্পেস। ওকে আমরা ধরে ফেলবো, সমস্যা নেই। ঠিক আছে। So one thing is clear that this fake ID is not from cse1. হ্যাঁ, এই হয়ে গেছে। অবশ্য ষড়যন্ত্র করতে পারে, বলা যায়, বুদ্ধিমান হতে পারে। So that's all about today's names. আচ্ছা, এখন একটু তাড়াতাড়ি করে অ্যাটেন্ডেন্সটা নিয়ে ফেলি। আচ্ছা, about one thing about the Google Sheet, খেয়াল করি। Okay, where is it? Oh, about this Google Sheet, have a look here. So previously I just written that what is the lecture title, right? But in the last 2 lectures, I have tried to arrange it in a bit different way. Okay, so I tried to show that what is the content. Okay, so I tried to write it down here. So what are the contents? Then, for example, here another Rabin Karp algorithm. Then what is the material? So mandatory material is lecture video. Then I try to give you 2 additional links. Okay, so one is on the both of them are on Rabin Karp algorithm. Okay, so I found them useful, easy to understand. So if you find it difficult to understand my lecture by some way, you can check them out. Okay, however, both of them are covered in the lecture. Okay, that's why I have written optional here. So if you find optional in the side of any material, if you do not cover it, no problem. But for this second one, optional is not written. Okay, so there is something in the video that will be necessary. Okay, for example, for this video, actually this person covered the code of Rabin Karp. Okay, although it is in Java, but the implementation might be helpful for some of you. Okay, so you can check it out. Similarly, for try lecture, this lecture. Okay, so the lecture video will be uploaded, and I took the idea from a blog, a Bangladeshi blog. Okay, it's a very good one, Shafai's blog. So maybe it will be difficult for the international student to understand. However, this blog has the code snippets. Okay, so the codes are already available in the blog, so you can check the code from there. However, it is optional because I have covered everything from this. Okay, I will cover everything from this blog. Even if you do not understand Bengali, it's not a problem. So the examples are same from here. Have a look. So these are the codes. You can directly take and run. Okay, it's very good page for learning Trie. In fact, many other things are also here. Rabin Karp is also here. I didn't check it. You can check it out. Okay, okay. So this is all about the material. So I will try to maintain a material list like this. Okay, reading materials. Okay, so let's take that attendance. Then
Two present.
3 present.
4 present.
6 present.
5 present.
7 present.
8 present.
5 present, sir.
9 present. 9 present.
Sir, 5 present.
আমি দিয়েছি, তুমি দেখতে পাচ্ছ না?
Sir, আমার নেট স্লো তো স্যার।
ও হ্যাঁ, আমি দিয়েছি 10 11
11 present. 11 present.
13 present.
14 present.
15 present.
16 present.
17 present.
19 present.
20 present.
22 present.
23 present.
24 present.
25 present.
26 present.
27 present. 28 present.
29 30 31
So 31 present.
32 33
33 present.
4
present.
5 6
35 present.
So 36.
7
37 present, sir. 38 present, sir.
41
Present, sir.
42
Present, sir.
44
45 present.
5 6
present, sir.
Okay, so thank you so much. The syllabus of the quiz will be up to Rabin algorithm. Tomorrow I will cover
Sir,
try.
47 present.
ID18 disconnect হয়ে গেছিলাম।
Okay, idea 18.
Yes, sir.
হ্যাঁ দিয়েছি আমি। ঠিক আছে,
Sir, roll 13 mic problem.
আমি দিয়েছি ওকে, সমস্যা নেই। ঠিক আছে, okay, so see you. Assalamu alaikum.
Sorry, sir.